Red.
All right, now that it's decided to play. Okay, gang. I don't care about whatever Prince Charles is doing. Alrighty, finally it wants to play. So I'll remind you guys before we get started that I'm going to do my best to get everything back to you. Anything that you've turned in, plus your credit for class and everything, I'll get it back to you as quickly as I can. But I am leaving for the airport this afternoon, and I will be gone until Saturday evening. So if you contact me between now and then, I will do my best. Texting me is going to be fastest. Okay, I'll see forum stuff, I'll see whatever else, but it may take me a while to get back to y'all. And even if you text, it may take me a little bit because I'm going to be wrapped up with whatever I'm dealing with my dad, which isn't going to be a lot of fun. Plus, hopefully trying to help my sister and her husband get their family safe. So, alrighty. So we were talking about ecology, ecosystems, population, all this fun stuff. So this was your homework from last week. So your air is going to be an abiotic factor. Obviously, how about animals? Biotic. How about bacteria? Biotic. How about heat? All right, plants. And this is the tricky one for most people, soil. Both. Why is it both? There you go. Yes, absolutely. Because it has dead stuff and minerals and rocks and sand and things like that in it. So it's both. All right. Heterotroph. You get your herbivore. In this case, eating only plants.
Carnivore.
There you go, carnivore. Your next one, omnivore, eats both. And how about this one? Gains energy by feeding on disintegrated or eroded matter.
Petrivore.
She's like, that's that word I can't think
I had
of.
problems with that one the first
Tritivora.
I don't know how long I spent on that one question. It was a very long time. After that,
I went forwards, then I went backwards, and I could remember.
So then you have your decomposers, break down your organic matter, and then your scavengers, which are going to eat your dead organisms. Now this one, if you put anything down there that looked close to sunlight energy, or even if you put 100%, like you were understanding, or producers or anything like that, I credited it. And then this is going to have 10% of your first level, 1% and 0.1. So your energy decreases as you go up the pyramid. All right, weather and climate. This is where we're going to start. Hey, Cole, would you do me a favor and remind the crew in the pub to keep to a dull roar, because Daddy, I know, has a lot of phone calls today. We've already made him crazy. So weather and climate, your differences. I mean, I've taken my socks off, but too hot. I'm sitting on an ice pack and it doesn't even know. That's gross. Teacher taking her socks off, but hey, I live here. Daggone it. All right, so weather and climate. So your weather obviously are your day-to-day conditions. They can change hourly, daily, weekly, all that, right? We have very unpredictable weather here, it seems, at least according to the people who get paid to predict it, because they don't always seem to, they don't even seem to hit the entire, they don't, what's it called? What do you call, I mean, bullseye is the center. What do you call it? Target? Is that what you call the whole thing together? They don't even hit the target, let alone the bullseye often enough, right? They're hitting the wall, somewhere else. And yeah, right. And then your climate is going to be your long-term overarching average weather, basically, right? Long period of time. So you got your greenhouse effect. Now, greenhouse effect, if you remember, if you were here for Earth Science, or if you're going to do it next year, we'll talk about it more. But it has to do with how the Earth's atmosphere will trap heat from the sun and keep it within the biosphere. And that's essential because not every planet, even those that are very close to us in our solar system, as close as very close can be in the solar system, they can be either really hot or really cold because they don't have a greenhouse effect. So it's absolutely essential that we have some of our radiation going out and some staying in.
And then there's Venus, which is just greenhouse gas.
Yeah. But it's very close to the sun too, compared to us.
Absurdly high of the greenhouse.
And super hot. Right. We are positioned just right.
And toxic. Toxic air. Like 600 degree.
Which planet brings us?
Jupiter, I think. And does Uranus do?
I want to say that it's theorized that either Neptune and Uranus raise diamonds.
I've heard that. I'd like to hear more about that because
Well,
that's
Elon
interesting
Musk will
idea.
have that figured out.
Yeah,
in
give him
2
time.
years.
Give him
Yeah.
time. He's
He
working
just
on it.
needs-
He'll send a Tesla up there and we'll have
Good
a
old
good.
Elon guy.
Ozzy, you are rude. Come here.
They'll need to figure out some way to get their past.
You don't stare at Michael's sandwich like it's yours. All right, so microclimate. What's our microclimate? All right, so your microclimate is going to be your small differences within a big region. So for example, this is stuff like when you go up to the mountains and then you have your valleys that tend to be cooler. Or what'd you find?
Indication of temperature peaks except between the K and the S, there's an E.
Because this was a British, I think this one came, yeah, came from a British site and it's like color where they throw in a U. Yeah.
I spell colors at you.
What's the other one? They do,
I do some of British,
Some British?
definition and some not.
There's a-
That's how I was taught.
Wait, he's at an award.
the RE and the ER. Yeah.
Yes.
There's another one too that they do that's different. Shoot, whatever it is. It's one of the ones that's written in our Declaration of Independence too. There's a word in there that we write differently now that I don't remember which one. Anyway, so anywho, so if you were in an area that's mountainous, for example, and you hike up to the mountain top, depending on how high it is, you might notice a big temperature change from the bottom. And then valleys, of course, you can notice different temperature changes there. If you're along a flowing water, it might be cooler along the banks necessarily than it is further away, right? So all these are microclimate. Are you gonna read every word? You're looking for something.
Oh my gosh,
I
because he's
can't
trying to
find
one up me. I said I would get kudo points this year, and he's like, no.
He's
Why would
very
you
serious.
Because
Yeah, why?
biology is my thing.
There you go. So
Or chemistry. do.
when you go as an adult one day, you will hopefully have the opportunity to purchase a home, and something you should consider when you're purchasing your home is the microclimate that's going to be created by the way it's facing. So if you have a house and part of it faces north, it might be too shady, whereas part of it faces south, that might be too hot. Now, what you want to watch, what's particularly important is where your windows are. So if you have the majority of your windows facing west or facing south, your house is going to be miserably hot because that sun's going to move around and it's going to sit there at this hottest part of the day, already hot, and shine right through your windows until it sets. So this house is pretty ideal because all this faces, what direction is that? Do you know? That's due east. Yeah, pretty much due east, right over the river. And we can watch sunrise there pretty much every day as long as there's no total cloud cover. And so the sun will move this way. And as well, we will move and the sun appears to move this way. And as it does that, there are very few windows on that side of the house. I think there's the ones in the dining room, and then there's one upstairs in my room, and that's pretty much the extent of it. So not a lot of heat pours in that side of the house. And then when you get around to the front, the boys' rooms get hot in the evening. So we keep our blinds closed there. So when you buy your house, pay attention to what direction it's facing. Also, if you like power washing, buy one where the majority of the front of it's facing where it's going to get all your shade. So you'll have to power wash constantly. So your HOA doesn't come after you for all the algae and moss that grows on it. Yeah.
I just power washed our windows to my dad.
Mm-hmm. It's a lot of work, isn't it? It's messy.
I spent 4.5 hours doing that.
I
wasted
believe you.
My whole day doing that.
Yep.
I've never been sunburned before. I came home,
Ugh.
my shoulders were peeling.
It's a
My
messy,
dad-
messy job.
My dad one day, a paint can accidentally fell out the back of his car onto our driveway and like broke open.
Not
And by the
fun.
time we got the power washer out there, it already like spread down the hill.
Mm-hmm.
I had to literally just sit there
Yep.
for like 2 hours.
And pressure wash forever.
washing the paint.
So changes in communities.
Would you stop it?
Why don't you sit on the floor there so you don't distract everybody? So this is an area where there's been some deforestation and they've replanted.
That's Tennessee.
I'm not sure, but the Smoky Mountain bit.
Look at that on the right, it looks like it's on fire.
Yeah, I think it's clouds.
I think it's just clouds.
Yeah, misty stuff.
It might have rained. That's
There's
what I'm saying,
a,
I can't see.
There's a show on Netflix now that Jason got sucked into called Big Timber. Anybody watch Big Timber? So it's a family in Vancouver, and they bought basically a giant piece of land that's the side of a mountain, and it's got some of the best timber in the world, like cedar and things like that. So they are constantly harvesting big trees and then bringing them back to their mill. And the thing that's, I guess, one of the things that's neat about it is they're always trying to buy used stuff and fix it up because they're trying to cut costs wherever they can. So they'll buy like $100,000 pieces of equipment at auction for $5,000 or whatever, and then they constantly break. But anyway, they're dealing with this sort of thing where they're taking down like an entire side of a mountain. And it's interesting, actually, if you like engineering kind of stuff or forestry or anything like where you want to see how people build things, put things together, make giant things move, neat show to watch, because they'll knock down a massive cedar tree on the side of a mountain, and then they have like a series of cables and things they can use to hoist it and move it. It's pretty amazing. So ecological succession. Yeah.
Okay, so one more thing.
Yeah.
So when I was like 4
Mhm.
to the time I was like 6 or 7, my favorite show was Swamp Loggers
Okay.
and Mighty Machine. Those were the two.
Mighty
And it was a lot of watching trees get cut down. for some
Mhm.
reason. But yeah, I was just saying, like, I love forestry. But anyway.
They took down the woods behind our last house to put in a subdivision, which was sad to watch. The equipment was amazing. They had this thing come in with these arms, and it looked like it was hugging. It would wrap its arms around the base of a tree. It looked like it was hugging it, and then it mowed it right off, and then dropped it.
I can't remember what they're called, but they did that in our neighborhood too.
It's the saddest looking thing because it literally looks like I love you, psych, and just levels it.
Yeah.
It was crazy. So ecological succession.
The tree hugger
So,
taking them.
Hopefully, after you get a good idea of ecological succession, what to look for, you'll spot this all over the county. Not hopefully because you'll see a lot of it, hopefully because you'll know what it is. So when you're dealing with ecological succession, you have species that repopulate an area in a specific order over time. And it's pretty much always that same specific order. So mosses and lichens come in first, right? And because they can grow on bare rock. They don't need good soil. Sometimes you're dealing with an area that has been destroyed because a fire has come through. Other times it's because of logging or, some sort of deforestation or construction. Around here, a lot of the time it's construction. You'll see it very frequently where, they'll, especially a couple of years ago, now we're in a housing boom, so not so much. But they'll level an entire area because they intend to build a subdivision, and then they don't build it because it suddenly becomes a bad time for building and buying, and they don't want to put forth the cost yet. So you'll see this big, red dirt clump suddenly start to grow things. So after you get your mosses and your lichens in, they've made the soil and the area sufficient for supporting small green things like grass. And then you get all the weedy stuff. And then that's followed obviously by your shrubs and your trees. Now, what kind of trees are the first trees to move in? Does anyone know?
Saplings.
They come in later. What kind?
Saplings.
Saplings, yeah, but what type of saplings? Somebody said pine, yeah. So your evergreens are gonna move in first. It's always your pines. So if you drive around Forsyth County, pay attention out your windows, seriously, for real. You will pass areas where there's an entire patch of land with all these little scrubby pine trees all packed in. Obviously, they're packed in too close to survive that way because there's too many of them in one space. Some of them are gonna outcompete others and you'll have a different amount that actually survives, but you will be amazed at how frequently you see it. Sometimes they're little short pine trees, sometimes they're 10-foot pine trees, but they're what come in first. And I can even think of specific places I've driven past, and there it is, clear as day, that they knocked something down, decided not to do it, and the pine trees are coming back.
I think we have an area like that in our neighborhood.
You probably do. Yep.
The one where the rabbits and the deer keep showing up.
Oh, no, that just used to be fun in general.
That used to be what?
That just used to be fun in general.
No, Bailey, all the stuff that's coming up there.
Yeah.
All of that is pine trees.
People pay attention to this.
Well, around here, usually it's either, it's not wildfire like it is in some places, but around here, it's either they've started construction and changed their minds for whatever, usually an economical reason, or it was a farm. It was a farm and now it's not a farm because somebody bought the land to put a subdivision in. They haven't done anything yet. It was nice big level land. And here come the pine trees. After the pine trees, you get things like your more shade tolerant trees and your deciduous trees, your hardwoods. They come in last. So if you find a forest that is full of hardwood trees, big hardwood trees, it's old. Yeah, exactly. And the bigger the trees, especially things like around here are big trees are like chestnut oaks. And there's the ones with the leaves. Their leaves are like this big leaves. Those can go a couple hundred years old and get, as big around as that table, huge, right? So the bigger and more prevalent the hardwoods, the older your forest is going to be. So then you have, that's what we call a climax community, basically. When it gets to the end of its succession, its ecological succession, it's reached the climax of its evolution from land with not much living in it to land that is fully mature. So what you have behind me out here that you guys are just digging around in is pretty close to climax. Probably could get closer, probably could get rid of some more of the scrubby stuff over time and have bigger hardwoods. Now, this was initially, I know, a farm. This area was a farm and forest. So it's hard to tell what was farm and what was forest. I doubt there was much farming done on this side of this slope, headed down to the river, which is a natural slope that wasn't constructed for the neighborhood. So we have this nice natural slope. Wouldn't make a lot of sense to do farming there. So we have a lot of big old trees along the edges of the river. So what's ecological succession is in your notes, series of predictable changes that occur in a community over time. And primary succession that's when there's no soil. So that's when you're getting,
What kind of birds are those?
those are mourning doves. They're a mating pair. They live
I
here.
don't think I've ever seen them.
And I think the bottom of that bird feeder is clogged because they've been flying there, looking at it and flying away, throwing shade my direction for the last day. So I need to go out there and like unclog the little holes. But see, they're mad at me. And there's a random ear of corn out there because we went to Super H, seriously, because we went to Super H Mart and they had that purple corn. I looked it up. It was called hybrid violet. I don't know. It doesn't look like corn you should eat, right? It looks like the Indian corn you decorate with. It was really pretty, but it was in the produce section and wrapped up like you'd eat it. So I tried to make it into corn on the cob and did not work. It was really starchy and like kind of hard. And
That's the one you put in it rice.
yeah, I've seen people do that. Really, the purple stuff?
Yeah.
I've seen that. And then I also saw it apparently makes good salsa. So I don't know, but we have some that we cut off that we had already cut.
You taped it to the.
Did I what?
Is it duct tape?
No. It's on a skewer and it's just kind of jammed down in the hole there.
Okay.
I put it there because I'm trying to get a where's the dog? A squirrel to come back and visit because it makes wherever the dog is he under there? No, it makes the dog run and it's fun. Anyway, your secondary succession is what happens when oh, squirrels. Yeah, they do. That's the Mark Rober, that was the thing they liked best, I think, of all the stuff he put up in his squirrel obstacle course. Was the
He
walnuts.
stole my pencil.
Come on, Alex. Don't be this guy. Don't be this guy. So when a disturbance changes a community without removing the soil, you get secondary succession, or you can also get that after primary succession is complete. And then in the process of succession, you've got older inhabitants that die out, new ones move in. So like I was saying, things are going to outcompete each other. And then secondary succession typically proceeds faster than primary succession because you've already got soil. It takes a while to make soil. Around here, what you're going to see first and foremost is secondary succession beginning. Your primary succession with your moss and your lichens. I can't even, those are hard words to throw together.
Moss and lichens.
Secondary succession with mosses and lichens. There were just a lot of S's.
Secondary successions with mosses and lichens.
Right, that would be primary. So anyway, I was going to say with the mosses and lichens, you don't see as much of that here because we don't have stuff that's stripped down to the rock very often. So then what's the branch of biology that deals with geographical distribution of plants and animals? That's going to be biogeography. So again, our Latin and Greek roots we're going to look for all the time, especially if it's a word we don't recognize. This one, you've got bio, which is life, geo, which is earth, and then what's graph or graphy? Like writing it, yeah, or in this case, mapping it. So you've got biogeography, meaning you're mapping life on Earth. So continental drift. All right, this is such a fun theory, and it's got so many different supporting points that it's really entertaining. Ozzy, don't you beg from Saba. No, sir. Come. That's my boy. Good boy. Come here. You little. Oh, stop it. Just come here. I didn't hurt you. Anyway, so this dude, Alfred Venegar. All right, now I don't remember if he's German or Austrian, but that W is pronounced like a V, so that's Venegar, Alfred Venegar. So he's the one who proposed this hypothesis just a little over 100 years ago, right? Not that long ago, that our continents were smashed together at least some point. Now we know they've been smashed together more than once, right? Multiple times, right? So he had 4 main points that he used to support his idea. So one of them is the obvious one. Look like puzzle pieces. I mean, if you look at our continents, especially if you were to take when you put them on a map, or especially a flat map, they're distorted because of the way you have to bend the lines to make it flat. If you were to cut them out where they were appropriately shaped and sized and stick them together, they fit really, really nicely.
He was seen as a crazy person, like a
A
psychopath.
lot of them were, man. What do you know about him?
So they thought he was crazy because he proposed this idea, and everyone was like, "No, it was just like this when it originally happened." And it
Yeah.
wasn't until what? Yeah, and so later, I think 1960. I don't know. It's like somewhere more recent.
Yeah,
It was found out, and his kids were super happy about it.
yeah.
He
So he
wasn't-
proposed this, as early as,
There's all of Europe.
Where's Europe?
So,
Where's North
North America's not in here or anything. It's just showing, this is basically like the Indian/Pacific Ocean portion right there. It's not
Where is
everything.
South America.
Yeah, they're not all
There's
here.
no Asia, there's no Europe.
This
there's
isn't
no-
the whole world. It's just showing part of it.
It's
So
the
anywho,
southern hemisphere.
you've got things called paleoclimate indicators. So this is stuff like evidence of glaciation. Where were there glaciers? So if you've done earth science, or you will be doing it next year, you either learned or will learn that glaciers, right, are these massive, massive hunks of ice that roll across the continent, right? Yeah.
It's been formed all the lakes in Minnesota.
Formed lakes in Minnesota, has formed lots of geographical features, and they also, because they're so massive, drag whatever they pick up with them along the way and leave a big old trail as they dump it and keep going. So you can use that data, where things are located and where certain features connect, to show where the continents were previously connected. And then you've got things that we call truncated geological features. So this is stuff like similar rocks found in different continents. Specifically, this example gives South America and Africa. So if you have rocks containing, nearly identical mineral content found in the same layers of Earth, it's giving you a clue that they probably were formed at the same time in a similar way. Do you want to sit, James? Are you good? Do you want a chair? You can drag in one of those, or you're good.
There's also a seat right there.
There's a seat over there. I think maybe people smell bad. And then lastly, we were outside. Fossil distribution. So this is what really applies to us in biology. So you've got evidence of species living in areas that are too cold or where water must have been, but you've also got evidence of species living on continents that are no longer connected. For example, they got this guy here, this Cynognathus, which was this giant land reptile. It says he's 3 meters long. So if you remember, your little square out there was 5 by 5. So that gives you an idea of how big this creature was, right? We're talking probably another half as big as that couch. Big, big, big reptile. And you can find fossils from him in both South America and Africa. Now, he's not swimming the Atlantic Ocean. That's not how it happened. Obviously, this reptile is not going to swim the Atlantic Ocean. And then you have things like fossils of this particular fern that are in Antarctica, South America, Africa, India, Australia. How's that happen? It's not like the fern's going to swim, hop on a boat. There were no boats, right? Boat fern. So then you have species dispersal. All right, species dispersal. This is among both plants and animals, and it usually takes place at the time of reproduction. So think about animals that move specifically for the purpose of reproducing. And then there's also just migration in general, right? So organisms can spread seeds or offspring by various different methods, such as water, wind. We'll talk about that. But then there are some animals that specifically move for the purpose of breeding. So monarch butterflies migrate every year for the purpose of breeding. And then does anybody know about salmon? What does salmon do that's so interesting? Yeah, where they were hatched, which is crazy. So you have fish, male and female fish, make some eggs and leave, head downstream. And the following year, their offspring will hatch and head downstream. And the following year, those offspring will swim upstream against the flow of water to where they hatched. And then they will spawn there, which is pretty crazy when you think about it. That's wild.
their place that they were hacked at just isn't there. They're picking new spots.
I don't know. That's a good question. I'm sure that is one of these things that impacts populations of wild salmon. You know, if there's a change in that ecosystem where they were hatched, or they can no longer reach it because there's now a dam. There are some really cool. They've constructed some, like you'll see them sometimes on roads where you'll see sometimes on roads, they've constructed tunnels for wildlife or bridges for wildlife. Now they're constructing bridges in aquatic environments, and it's pretty cool. So they've got like these little, it's like almost like a conveyor belt, sometimes with a little water where they can throw fish over, and sometimes it's like a grate that crabs can climb over. So they've managed to work around that when they've built dams and things that block off habitats.
Sort of salmon ladders.
Yep, that's exactly, salmon ladders, yep. So limitations to species dispersal. All right, so you've got your physical barriers, which is what we're talking about. We say, oh, they stuck a dam in the middle of the river and now animals can get around. So if you really love me, you'd swim across, says this little fox. So if this is a much bigger river, you can't swim across. This is the Mississippi. If there were only foxes on one side, there probably wouldn't be any on the other, because even if this guy somehow managed to get over here by himself, there would be nobody to mate with him, and he would just die, and his genes would die with him, and there would be no offspring. So physical barriers obviously are going to limit dispersal. And for example, like I have a friend that lives in Oregon near Mount Rainier. Is that Oregon? Washington, near Mount Rainier, sorry. And when she came to visit, she stayed like one night when she was here in the middle of a trip for something else. And Alex, let her focus. And her kids went outside to play, and she stopped them before they went out. And she said, there are venomous snakes in Georgia, because where she lives, there are physical barriers that prevent venomous snakes from coming to her area. So any snake her kids find, they can pick up and it's not going to bite them. And apparently they like to do that. So it's not going to bite them and injure them. So they grab all kinds of snakes outside. So she stopped them. She's like, don't go looking for snakes in Georgia. Yep, they're back and they're mad. So how many venomous snakes are there in Georgia? Do you know how many species? Yeah, roughly 3. What do we have?
I want to say water moccasin. We have copperhead. We have that one that looks like the coral snake.
We have the 3 main that are indigenous are copperheads, water moccasins, and rattlesnakes. Right, which you don't see too often, but they're there.
Yeah, well, I know there was a diamondback skin in our woods.
Oh, cool.
It was really cool. I was so quite proud.
That's cool.
Anything with snakes, that's a question for my sister.
Which one? And should I think
Bailey's second.
I don't know which type of snake, because I stayed away from it. But there was this dead snake that was just on the road that I almost ran over by.
Oh man. So we had about a 4-foot king snake last week, and my mother stepped out the door to let the dog out, and it was along the edge of her door, like right up against her sliding door, and she didn't see it. She stepped right over it. And then Cole came and got me, because they're great and they're not snakes you want to hurt because they eat copperheads, but the dogs would go after it and we didn't want it to get hurt. So I spent 5 minutes trying to catch this thing, finally caught it on a rake, and then I had to twirl the rake because it kept climbing up. So I had to keep twirling so the bottom became the top, and keep going and toss it over the fence. Now, when it landed over the fence, it got stuck in the fence and in all the vines along the fence. So then I had to fight to get it off the fence. I ended up going around the other side of the fence and grabbing its tail and yanking it down, because it kept running from the rake, and it was going like under the upright parts of the fence, like half of it. It was making me crazy because it was such a battle. So when we finally got it down, it tried to come in through the kennel wire. So we tried to get it out. But one of the things it did was, it would strike at you, even though it's not going to hurt you because it's not venomous, but it shook its tail like a rattlesnake would, because it's imitating a rattlesnake, because those are venomous snakes in its community. And somehow they know that, and it's shaking its tail at you like, look at me, I'm scary, I might bite you. And, I know darn well that it's not going to hurt me. Yeah.
Mom's ran over a king snake with the lawnmower.
Oh, I've run over him with my van, and I don't mean to. Yeah.
So 2 things, actually. One, I just saw a snake Monday, or not Monday, Sunday, because we were moving furniture and I almost stepped on it.
Oh, fun.
But
Was it in your house?
no, it was on the sidewalk. It was only about yay big.
Oh,
still.
yeah,
And 2, I found out actually that it's illegal to kill snakes.
it is. In Georgia, it's illegal to kill them. Although people all the time want to kill them just Leave them alone.
Bro, I live people.
Yeah,
Just for fun.
I know. Yeah.
My
Yeah, leave 'em
grandpa hurt his
alone.
back.
So competition. Okay, this is a barrier to dispersal. Competition. All right, you can compete for a lot of things: food, space, water, mates. In this case, we have vultures competing over what I'm assuming is, I don't know, a zebra rib cage.
Wait, why are they competing over it? It's all already been
It's already
eaten.
gone.
Well, maybe there's some little bits left. You don't know,
I was gonna
Alex.
say.
Maybe they want the best, I guess,
The
like-
competition is
They
there.
want the bone.
And then lastly, climate. All right, so if you have a shift in climate, now weather, most things are going to be able to weather the weather, right? That they're going to be able to handle change in their weather. Organisms that live in a particular climate, they're adjusted to it. But if you have a shift in your climate, and Earth's climate is constantly shifting, always has been, just like continents are moving, climate shifts. Earth's always changing. It's like a living system, right? So if you have enough of a shift in climate, it may make it so that some species are no longer suited for their ecosystem because the climate has shifted. So you'll hear a lot about that when people talk about, you know, polar ice caps diminishing and polar bears running out of habitat. That's the kind of thing that's always happened since, you know, since Earth's been Earth, right? It's constantly changing. But that can definitely cause some species to not survive. And, you know, if you look at the fossil record, you see a lot of that sort of thing. So what's an exotic or invasive species? What's that mean?
Something that's from a different ecosystem but has been moved here.
It's not
Yeah.
normally in the certain.
Yeah, like those Joro spiders we saw out there. Now those Joro spiders are big and they're freaking people out. We had one last year that was hanging, it spaced itself between my chandelier that I have outside and the trees, and it was like as big as my thumb. It was probably 2-3 times bigger than any of the ones you saw today. Big sucker, beautiful. I mean, beautiful. Those are relatively harmless. This dude, however, does not belong here. And
Is that a Gila monster?
it's not, I can't remember, I'm gonna find the name of it. I should have,
Komodo dragon?
I thought I put it on. No,
People eater?
it doesn't belong, and it's been
It says-
released, and it's been spotted more than once, I believe, which implies that there are more than one of them because it wasn't like it was spotted in the same
Fulton
place.
County. All right.
Yep. So that's not too far from here. Should you see one of these, they're apparently not good for you.
What's the
But
name?
it's called like a black and white. I can't remember what it's called. I have to look it
There's a
up. It's a
skill
black and
for-
white something. There's a what?
There's a skill for animals.
Yes. Yeah, apparently. There you go. So anyway, that's a beautiful critter, but he doesn't look very much at home in the clover and pennywort there. I don't think he belongs in that.
Don't think so?
Nope, don't think that's for
I don't
him.
think that's the camouflage she's supposed to use.
Yeah. So when we're talking about means of dispersal, so means of dispersal for species, we're often speaking of their offspring in particular. So seeds. So obviously you have seeds that can travel by wind, water, or animals. Now, when you blow the little dandelions, oh, it's so fun to blow the little dandelions. You're throwing all those little dandelion seeds back into the lawn that your parents probably are trying to keep the dandelions out of. So there's that. The milkweed ones, those are the big fluffy ones. We used to call them fairies when I was a kid because they float around. And then the maple ones we used to call helicopters. You ever throw them and they spin, right? Okay, so they're meant to do that. They catch the wind and they further disperse than just on the ground. Uh-huh.
We have Japanese maples in our backyard,
Mhm.
so those seeds are common.
Oh yeah. So
And
now,
we-
go ahead.
And we have saplings from them.
Oh yeah, I'm sure you do. I'm sure you do. So now you have also let's look at the ones by water. So lotus seeds in particular pop out of those. Yep, cattails. Now cattails can go by air too, because when the cattail, if you've ever seen it, it looks almost like a hot dog on a stick, right? And when they explode, But it tends to be layers of these little seeds that they strip off and they hit the water and they do spread. Some of them poof away into the air.
Are there different names for cattails?
Probably.
I think
I don't know. I've always just heard cattails though.
there is another.
I'm sure there's.
My
Scientific
grandma
names,
calls it something way different.
Yeah,
I'm sure it was something. Yeah. I'm sure everybody has names for theirs.
Horse crushers.
Oh, okay.
I've never heard that.
And then
I
the
don't know.
coconuts are meant to be spread by water, which is why they float.
Yeah.
They wash up on the shore islands. Oh yeah, they float. It's especially when they're within that the big green husk, they'll float really well. And coconuts have a lot of air inside. If you've ever,
Yeah.
here's the thing, I love fresh coconut, but it is so much work. There's so much
There is.
work. You got to get they're usually like this big,
Yeah,
right?
there
And
is.
yeah, and they have those little 3 little
The bone ball.
spot. Yeah. And you take a screwdriver and you got to knock at least 2 of them open so that when you pour, out the liquid, you can get air in, right? So you're not just sitting there with the vacuum is not working. And then you can crack them open, but the amount of work it takes to get the meat out of them.
Meat?
Yeah, the flesh.
Coconut meat.
Mhm.
It took forever.
Don't you just scrape it?
Yeah, but it's still, it's a lot of work. It's hard, yeah.
Isn't it just?
So then we've also got,
The white stuff is edible.
we've got the types of
stuff?
seed.
Isn't it just juice?
There's milk in there and then there's the actual flesh, yeah.
Flesh.
Have you ever
It's
seen
like a
those
pumpkin.
Netflix on, like, a
Yeah, like a
cake or
pumpkin.
something?
Except if a pumpkin were to have juice in the middle or water in the middle. Mhm. So you have some seeds on some trees and stuff, flowers, whatever, that will burst open and explode like that. And then obviously the ones we spread, but if you look at the ones over here where it says by animals, we have in particular, like there's a weed that grows all up in our yard and it's a little viney thing. It has these little tiny green spherical seed pockets on it and they're like Velcro. They're burrs, but they're not the kind of burrs that hurt. Like there's some burrs that when you're pulling them out, you make your fingers bleed, because they're really sharp. These are like Velcro burrs and they get in the dogs and they get carried everywhere, which is why they're like that. That's the whole
The
purpose.
guy invented Velcro was because
Yep.
there was birds in his dog.
Uh-huh. Mm-hmm. And then blackberries are kind of the same way just because of the thorns and whatnot. But these also can get spread by if this little dude eats this blackberry, this little squirrel, and then he goes and poops somewhere. Now he's planting blackberries somewhere else. And not, so here's the thing, if my raspberries that grow on the side of the house, they're finally just about done. They went all summer long. They were great. They're just about done. But I have a couple chipmunks that live here and I've seen them run over there and stuff them in their little cheeks and run away. So somewhere that chipmunk is going to go poop out all those seeds. And if you are a raspberry, that is what you want, man. Because not only has your seed been put somewhere else, but it's in a big old pile of fertilizer and it doesn't get any better than that. That
Yeah.
is like perfect for you.
In our old house, we had blackberries and
Mhm.
raspberries that were just there behind our house. when we
Yep.
moved in.
I think at our house we have blackberries, both two colors of raspberries and blueberries.
Wow. That sounds good.
Blackberries, black raspberries, red raspberries, and blueberries.
Nice. So we've got biomes and aquatic ecosystems. All right. So our aquatic ecosystems, we'll come back to. We'll do our terrestrial biomes first. So here's your terrestrial here. When you see terrestrial, there's that root, terra, meaning earth, right?
The tiger.
Yeah, the taiga. So this is the interesting thing. The taiga and the boreal forest are kind of the same thing and kind of not. So when you hear people refer, okay, if you're talking about that region in general, and you're using the two terms separately, then you're probably talking about the boreal forest being the southern part and the taiga being the north part of the same biome. But if you're just talking about them with respect to all the other biomes, some people just use them interchangeably. I've usually used taiga forever. Now boreal forest is becoming more of a thing. So it's kind of one of those language things where it's evolving to some degree. So when you look at the rainforest, it's gonna be our first one here. You have two different types of rainforest. Where are you surprised?
We have rain.
We sure do. Yep. And we have both types of rainforest here. So your two types, yeah, we have tropical and temperate. So your tropical rainforests are the ones that are found near the equator where it's nice and warm, right? And these are the guys that have,
Is it ugly technically?
I don't, yeah, probably. This is Florida, right? So, yeah.
Right, it's North Georgia.
Yeah. Oh, North Georgia?
Sorry, South Georgia.
South, I was, yeah.
Yeah.
We have one of the two temperate rainforests in Georgia. The other one's Seattle.
Yeah, where are you thinking? Where's the other one you're thinking of?
What year?
Yeah.
Oh, it's in Canada.
Oh, okay. I haven't been over there to that. So you've got your three levels of your tropical rainforest. If you've ever talked about tropical rainforest or said it before, you've got your canopy, your understory, and then you've got the forest floor. Hey, where you going? Looking for crumbs. Your canopy is obviously where all your sunlight comes in. Your understory is where, if you've ever watched nature specials, you see the monkeys and the birds swinging around. Oh, they're in the understory. And then your floor is where you're going to find all your interesting insects, amphibians, all that business, right? So
What
then
if the insects climb trees?
some of them do. Your temperate rainforests, though, are what we have when you think of Seattle, for example, where it rains constantly. That's a temperate rainforest. So we do have rainforests here in the US. We have a big one right here along this coast. And if you look, you've also got similar right here. If you think of the earth like a mirror image with the equator in the middle, right up here along this west coast, right here along this west coast, you've got temperate rainforest. So the world's largest rainforest, your Amazon, right? I only took a few of the top 10. There aren't all 10 here. I started it and then
It
they,
says top 10, but you only took.
yeah, I took 4. I gotta go back and change that. But anyway,
I was watching it there.
yeah, there you go. So your Amazon rainforest is 5.5 million square kilometers, massive. Especially when you compare it to the second one, which is only like 1.8 million square kilometers. So that's how much bigger the Amazon is.
Who owns the Amazon company? I forget.
Oh, there's
Jeff
lots
Bezos,
of
right?
individual
Yeah.
ones. Oh, you mean Amazon that, yeah, that's Bezos.
The
Yeah.
Jeff Bezos Memorial
I
Rainforest.
don't think he owns it anymore, does he?
Yes, he does.
Okay, I couldn't remember. I thought he sold it. I don't know.
Jeff Bezos.
I would never sell it if I were him. Okay, quit the pillow fight.
He doesn't own all of it.
Yeah, I know he's got shareholders and stuff. So then the third one here, that's where I left off. Your third one is going to be your New Guinea rainforest. And that one's much smaller. So now you're down to, 2,900 kilometers squared. So much smaller. So your taiga, God, quit. Your taiga. All right. Taiga / boreal forest, this area here. So this is where you've got all the trees that you have are cone bearing, needle leaved or scaly leaves. That's what's up there. And what now?
So pretty.
So pretty, absolutely beautiful. So this is found in northern circumpolar, right? So around the North Pole regions, long winters, moderate to high precipitation, which would be snow, right? And then taiga, the word taiga is actually Russian and it means little sticks, land of little sticks. So when you think about it, all those tall conifers, right? All those tall evergreen trees is land of little sticks. And then in Russia, the world's largest taiga, is almost 6,000 kilometers from the Pacific Ocean to the Ural Mountains. So that's this big stretch you see right in here, right? And it was completely glaciated or covered by glaciers during the last ice age. Soil beneath has permafrost. So you're edging towards tundra, which is always permafrost, right? Your temperate deciduous forest. This is where we live. Okay, we live in a temperate deciduous forest. See us right there? We're orange. That's us. And here's the interesting thing. The largest temperate deciduous forest is the eastern part of North America where you live, but most of it's gone. By 1850, we had deforested most of it for agricultural purposes. So where we live was once the biggest, and now it's kind of not so much as impressive. But in this biome, you've got deciduous trees. So deciduous trees do what? What do they do? Yeah, deciduate. They shed their leaves. They have the big wide flat leaves and not needle leaves, right? That doesn't mean we don't have evergreens. We do, right? But they drop their leaves. And then we have cold winters, warm summers, 4 seasons generally, right? Moderate amount of precipitation, and we have different stratums of trees. If you were to go through them all, you'd say we have a tree stratum zone and a small tree and a sapling zone and a shrub zone and an herb zone. And that would be how you would break our forest, like you would do a tropical forest. Now your grasslands, we have grasslands too, right here in the middle, right? Now what you get in the grasslands is you've got your savannas, which are the grasslands that you think of when you think of Africa and whatever. And for whatever reason, they didn't color that in on this map, and they should have. There should be a lot of grasslands right in here. So these are tropical. So right along the equator in here, there are a ton, right? And then you've got temperate ones and steppe. Now the steppe ones are more arid. They lead towards desert areas. So the thing to think about here is in grasslands is where you find your grazing animals, lots of grazing animals. So when you think about what's grazing in Africa, like what kind of animals do you see like grazing, wandering around? Zebras, that kind of business. All right, so what's the grazing animal right here in the middle of North America? Bison, and that's, yeah, we lost a lot of them too, but that's what's supposed to be there, right?
Buffalo Bill.
Yeah, there you go. That's what's supposed to be there right in the middle. So then you have deserts. All right, deserts cover actually most of the, or a fifth of the planet. And aside from aquatic or marine, it's one of our biggest biomes. And you've got different kinds of deserts. You've got your arid deserts, which are the hot ones. So when you think about, going out here to the wild west or Phoenix or whatever, that's Phoenix is not so wild. Well, it is, but not in the same way. That's what you're seeing there, right? Semi-arid ones, hot. They're not quite as hot, not quite as dry. But then you have your coastal, and those go right along the western coasts of countries here.
Should it be the desert is a dry, terrestrial biome,
Yeah,
Really go
those
for
are-
it, right? It is.
Those are two adjectives.
or is terrestrial in this case an adjective?
Yeah.
Or is terrestrial biome like a two-word noun?
No, it's an adjective because it modifies biome.
There should be a comma between them.
Yep, right there. So then you've also got cold deserts. Now, these are the ones that are hard to think of because when you think of deserts, you probably think hot. But there are cold deserts, and your biggest desert in the whole world, it's Antarctica, which is
The biggest desert is in
Antarctica, which they don't get much precipitation, which makes them a desert, although it's very cold. As cold as you're gonna get, right?
They
Yeah.
don't actually get snow.
Yeah, they don't get, and it's just ice. And then your Arctic followed by that. Then you get your Sahara, Arabian, Gobi, these things that you know as deserts when you think of deserts. So yeah, your Arctic and your Antarctic. Your Antarctic's down here, your Arctic's up here.
Dang, public school lied to me.
Public school lies to lots of people about lots of things, friend. Alrighty, so our tundra.
Sahara is the biggest desert in the entire world.
So yeah. So your tundra up here, this is kind of where you get a little overlap between desert and tundra. So technically, your Antarctic and Arctic regions are really kind of both, right? They qualify as cold deserts, but they also qualify as tundra because it's always permafrost, right?
It's the spot right in the middle of the continent.
So that's interesting, right? Right smack in the middle here. What's there? Do you know what's there?
And
Russia.
No, it sounds to me Russia. It's
Right here. So this is India. This is
Oh,
China.
mountains, Himalayas.
Yes, the Himalayas. And why would that be a tundra?
snow. and-
Altitude, elevation. They're
So that-
super
that-
high.
The little dot is right there. I guess that's your.
Oh, right here? This is the Alpine tundra. So yes, this would be like Switzerland, Germany. Mhm.
Slightly north of Italy. It looks like.
Yeah, this is the Swiss, like the Alps. This is the Alps. These are the Himalayas. And these are going to qualify as tundras because they're so cold that by the time you get to the top, you've got really major permafrost pretty much all year. So you've got winters are long, dark, cold, typically, in these regions, right? In your polar regions. And you've got permafrost, but then you've got your Arctic tundra and your Alpine tundra. And that's how you're going to divide them. And I think technically there's probably like a subterm for your Himalayan and all these other random little mountain ranges, like right down here. That's more through there.
That's where Machu Picchu is located.
So your tundra is treeless, polar, desert. And then you've also got these other regions that are not polar, but treeless. There are not trees on the top of Mount Everest. No trees, nothing growing. So you get to your aquatic biomes now. All right, aquatic biomes. You've got three main categories. And of course there's subdivisions, but you've got freshwater, marine, and estuary. Where is a good example of, somebody give me an example of where to find an estuary in the US?
Chesapeake Bay.
Mississippi.
That can be one. Mhm.
Mississippi.
Mississippi Delta. Yeah.
South Carolina.
Okay. Yeah. All along all the coast, pretty much. Yeah. So if you were to go to, if you go over to, if you go to the East Coast and you go like Jekyll Island, Cole, all that stuff along there, there's estuaries there. Our best known ones would probably be like the biggest sort of, poster boy, I guess you could say, estuaries are those along the Mississippi Delta, which is huge, Mississippi Delta. So you've also got zones within your water, right? So you've got your plankton at the top, your nekton, which are your fish, and your bathos at the bottom. And here is a more specific one. It's going to show you how deep and all the various types. And we talked, I think, last week a bit about how phytoplankton in particular are responsible for most of the world's oxygen. Like this is what you're breathing. You're breathing products of phytoplankton far more than trees.
I want to say that it's also fed by minerals and the like, partially.
What is the phytoplankton?
Yeah.
Well, yeah,
a lot of
to a degree.
minerals is
Especially the
rock
zooplankton
eroded from the.
that's dissolved in the water. Yeah, I mean, especially stuff like the zooplankton. The phytoplankton in particular tend to be photosynthetic. Yeah.
Why do they name that jellyfish?
What?
What is it? Oh, man of war. Have you ever seen one?
Yeah, I have like aquarium stuff. but
Yeah.
what have I done?
I don't know. I guess he looks mad enough to go to war. He's huge. I'm not sure.
Man,
Right.
of war, why they name it like that?
Yeah.
Women of war.
So we should all act like something really funny just happened. Not too loud because Jason's on the phone, but maybe it'll wake her up. So like, on the count of three, just laugh hilariously, but not too loud.
What did?
Okay. Yeah. So. There you go. All right. So anyway, moving on. So then next you've got, sorry. Next you've got your, I scrolled backwards with my fingers. You've got your benthic realm. Okay, that's on the floor of the ocean. This is where you find your sea spiders, your fish, red-tailed fish, eels, things like this. Anglerfish, who, if you don't know what an anglerfish is, look it up. Amazing. There was one in Finding Nemo, the thing with the light.
That's how I learned when
They're fun. All right, so estuaries. Your estuaries have basically this intertidal zone, the Nereid zone, and then your oceanic zone. And this intertidal zone is where most of this business is taking place that is specific to estuaries. So you've got water from the ocean moving in, salt water, fresh water coming from your continental freshwater sources. So rivers, lakes, runoff, mixing together in your estuaries. Does anybody remember the name for water that's part salt, part fresh? What do you call that kind of water? Do you remember?
Mix.
Brackish. Yeah, brackish water. Brackish water is what you get when you've got a mixture of salt water and fresh water. It's brackish water. And the organisms that live in estuaries tend to be pretty specific to estuaries. And then there's some that just really capitalize on them. Like a lot of those fishing birds that you see, like egrets and herons and stuff. They'll live around freshwater sources, but they love estuaries. And what were you saying?
Oscar.
Yeah, osprey, that's a great example. And then there's a lot of those little periwinkle, snail things and crabs. They all love it there. So you can see where estuaries exist pretty much around the edges of all the continents, because that's where you've got your seawater moving in, your freshwater moving out, where your river meets the sea, like that good old song from Emmett Otter. Love that show. Love that show. So that's what you get with your estuaries. Now your fresh water, obviously lakes, ponds, streams, things of that sort. And if I blow this up a little bit, you can get a really good picture. Where is all that big freshwater area in the US? Do you see? Can you recognize? There's our Mississippi, right? Clear as day, and right there in the middle. And then what do you suppose this would be?
Amazon.
That's the Amazon. Yep, there you go. And then there's all kinds of rivers that run through here, like what's this one? The Yellow River coming through China. Yeah, Yangtze, all that kind of business. So you're talking about a fifth of the world. All right, so about the same as deserts, actually. You've got your fresh water. And it has to have less than 1% salt to be considered freshwater. Usually runoff or groundwater. And then you've got, lastly, your marine biome, which is by far your biggest biome, your biggest aquatic biome, your biggest biome period on the whole planet. Clearly, because most of the planet is ocean water, right? So you got to have your salt water. And this is where you've got things from your microscopic cyanobacteria, your blue-green algae, to your blue whales, all thriving in this same massive biome because it has such diversity within it from the top to the bottom. I mean, your deepest parts of the ocean have zero light, right? No light penetrating, but lots of chemosynthetic organisms down there, right? That are producing their energy from, deep sea vents, for example. There are some nitrogen-based organisms down there. It's pretty fascinating. And then this was your, this one was in your homework. So if you have your binder out, you may want to look, but we're filling in as we go. So what biome is warm year round and wet? There's your tropical dry forest. And then you've got here hot and wet year round for your tropical rainforest. And those were some examples. You probably put something similar in: plants, broadleaved evergreens, that sort of thing. Tundras, cold, dark. Huh? Yeah, sure. Absolutely. But I still have your answers for you. You got your temperate grasslands, you got your hot, warm summers, and you've got lots of grass because it's called a grassland. But there are trees. They're usually scattered trees. I'm sure you've seen the nature programs of, like, the giraffes are eating out of the trees and the zebras are eating the grass off the ground, right? And then what has your low precipitation with your variable temperatures? That's your desert. Anybody ever stayed in a desert, visited a desert? Compare your night to the day.
Yeah, that's, I stayed.
It's shocking, isn't it?
Yeah, it's cool. It's
Yeah.
also like pitch black. Yeah.
Mm-hmm.
Like, it was crazy.
Y'all are funny. So yeah, nighttime in the desert, it can go from 100 degrees during the day to 40 degrees like that. And that's because there's not, if the air is really dry.
Don't do it.
Okay, the air is really dry. There's not a lot of humidity to trap a lot of the heat in. And so what you get is a massive loss of heat as soon as the sun is no longer part of your picture. And then where we are, you guys know how everything plans out here because you live here. So you know what to expect and you know what it's like. So what are the four main factors that affect aquatic ecosystems? Your water depth, your temperature, your flow, the amount of dissolved nutrients. What does the depth of water determine? That's basically the amount of light. So therefore what lives there. And then what? And then what distinguishes your photic zone from your aphotic zone? There's your word photic, that's light, whether there's light or not light. So primarily, climate conditions, temperature, and precipitation that determine the plant or what determine the plants that grow in a region. And then the plants determine what animals live there because you need the plant, animals need the plants. Deciduous forests have a variety of habitats, you know, because you've been in one today. Your point along the shoreline where your high and low tides is your intertidal zone. These are all things from your notes if you had them open to check. And then interestingly, those organisms that live in your intertidal zone, have you ever seen like oysters in their natural habitat? They tend to be hanging on to stuff or barnacles. They're hanging on to stuff and they are contending with the water level disappearing, the water level coming up really high. And sometimes fluctuations in the salinity, how salty it is. And plus sometimes where they are, there's waves pounding them. They go through storms that come along the coast and they manage to survive perfectly well. And then these were all notes, and I think you have all that. So now populations. Okay, populations. We start looking at populations. There are different ways that we study them. Okay, so we can do what we call direct and indirect observation, sampling, and mark and recapture studies. So mostly what you guys are doing today was direct observation. But you could have done some sampling, for example, and you probably could have done some indirect, and you may have done some indirect. So we'll come to those in a minute. So your direct is the most obvious. You look at a little pool with crabs in it and you count the little crabs. There are 5 crabs in this pool. Ta-da, that's your answer. That's kind of what you did, right? Like, how many roly-polies do I see? Uh-huh.
Are those also barnacles in the picture?
Those are barnacles in the picture. Yep.
Small baby barnacles.
Mm-hmm. Yeah, they are. They're pretty cool.
Juvenile.
I like barnacles. I think they're really neat. So the next thing you do is indirect observation. All right, so this is a type of swallow, a bird that it's called a cliff swallow. And they build nests out of mud. Swallows build nests out of mud. If you've ever seen the little mud net, they tend to stick them up like under the ledges of buildings. We had some at church. They got under, like we have a little peak thing, like a little tiny shelter area before you go in the door. And they got up in there and they started building their little mud nests, which was cool. But the problem was they pooped all over where people were walking in. Like the whole area was covered in poop. People were dodging poop because that's where they were. So we had to put the little nail thing along there when they were done and the babies had moved out, and we cleaned out the little nails along there so they don't stick their nests there because the little nails make it a place they don't want to live. But this is the thing with swallows. So these cliff swallows, for example, if you know the average clutch size, so you know that they have an average of say 4 babies, then you go and you multiply the number of nests you find by their average number of babies, you can get an idea of that population. You didn't count them directly, but you're using the information you have to make a judgment. Now you could have done it out there. You could have said, you know, in this square foot, I found 2 roly-polies, or in the square yard, I found 2 roly-polies. So I had 25 square yards. So I'm going to get, you know, you could have done the math and made a guess. Sampling is the same kind of thing. That's, well, actually sampling is what I just said with the roly-polies. That was silly of me, backwards. Sampling is when you can't count all the things, all right? I would not want the job of counting all those birch trees. That's a few too many birch trees. You'd be there 1.5 years. What you can do is take an area, like I was just saying with the roly-polies, take an area, count how many, multiply by how many of those units you have to get a guess as to how many are there. And then lastly, you can do this thing, which is mark and recapture. Sometimes mark and recapture involves actually catching the animal, tagging it, letting it go, come back a year later, catching it again, or catching it in a different place. But they've gotten better with some of this technology. So this sea turtle here is wearing a radio transmitter. And they do this now fairly often. It's pretty cool because they can do it with marine mammals, they can do it with sea turtles, but they can very closely follow migration patterns because they don't just see where it starts and ends, they see the whole thing in between, which is really cool because you can follow this sea turtle everywhere. So sometimes in this case, it says you can mark it with a dot. Like you could catch these sea turtles, you could mark their shells with a dot, you could come back next year, pull in the same number of sea turtles, how many of them have dots, you know, where'd they go, where'd they come from? Or you can do this, which is almost like having, it is like having a live stream feed to where your turtles are. It's really cool. And they do this, like I said, they do this with land mammals too. They put radio transmitter collars on, especially like herd animals, they'll put collars on them and you can watch them move, like antelope or things like that. Pretty neat. All right, so if you have a garden and it's a 12 by 7 meter vegetable garden, and in 1 meter you find 2 toads. So this is how you would apply sampling. So each one of these little cabbage heads is going to be a meter here, a square meter. You're like, okay, I got 2 toads there. So how am I going to estimate that whole population? Well, what you're going to do is you're going to end up doing your math, like we were just talking about with the roly-polies. And
168.
yeah, look at them all. Toads. So this would be much easier, don't you think,
There are no frogs there.
than trying to count these toads. Counting these toads would take you a year and a half and it would be miserable. So what'd you say, Alex? 168? Right on. 168. That would be, I know, I'm surprised. Alex got math right? Huh. You know, I've heard that I've always wanted to do this thing where if you're riding in a car and there's a trailer, a tractor trailer, the car carrier kind, you know, with no cars on it, but it's a ramp. You get up behind it. And when people are like that, you just suddenly go, ah, and it looks like you're about to go, or the ones where they're towing a car backwards and the headlights, you know, aren't on, but they're facing you.
Those are funny. Those
Yeah.
videos are hilarious.
Yeah, that would be fun. What could we do like that?
I want to do that.
What are we going to do?
Just trying to make sure everybody's awake. You know what the thing is we're outside in the heat and we come in and we eat lunch. And then everybody's like, I have eaten lunch. And now I am done. Oh my word. Okay, so let's think. What's a good password? Okay. Password's going to be population. So if I say it, you just find a good reason to laugh, right? So everybody would just laugh whenever I say that. There'd be no reason. So this population can increase with a rise in birth, right? Right? Okay. So if you have more frogs, your population's going to increase. But it can also, your population can also increase with immigration, right? And that's when things are moving in. All right. And it can decrease. What? Ah, where'd that go? I was talking about population. Right? I think, oh look, my animation didn't work. Anyway, you can decrease your population, obviously, if you have a rise in death, and you can also decrease your population with emigration. Population is fascinating. All right, I love population. So anyway, bunnies are an animal that is known for increasing its population. All right, really quickly. So everybody thinks that's a funny word. And here we go. So we're good with that one. We can leave it for a while. So population size. Populations can change in size when new members join or when others leave. Yeah, we're good. And then, yeah, for now. So births and deaths. All right, what's this mean? So if you have a birth rate that is high and a death rate that stays level, your population is going to increase. If you have a birth rate that's low and your death rate stays high, your population is going to what? Decrease. All right. Now, what happens if you have a low birth rate and a high death rate? It's going to like super decrease, right? This is like in churches where they say if you have more funerals than baptisms, you have a problem with congregation size, right? Same thing. Same thing. Now, if you have a really high birth rate and a really low death rate, you'll get a lot too, right? And then you can get overpopulation, true. So the population statement basically says if your birth rate is greater than your death rate, your population size increases. And if your birth rate is less than your death rate, your population size decreases. So that's what you're looking for. And when we talked about invasive species before, that's another interesting thing about rabbits. Do you know where rabbits are a huge problem?
Australia.
Yeah, why?
Because
They
there's
don't-
not a lot of things that'll kill the rabbits.
Yeah, there's not a lot of things that will kill the rabbits.
See, that seems so weird. 'cause
Yeah,
like,
there's no like natural food chain predator there, right? So European, yeah, right.
Wait,
So
does
you're,
that make the rabbits the apex predator?
so you get, what you get is these Europeans who start populating Australia and like to hunt for rabbits to make into rabbit
They've already
stew.
like a dozen
So-
or 2 dozen.
Yeah, they bring a couple rabbits over to hunt for fun. And then you get this issue where they have taken over everything. And have you heard about the rabbit fences? They build fences that they dig deep, deep down, like 3 feet down, because the rabbits just burrow under them otherwise. Because they started intelligently by trying to put physical barriers up for this burrowing creature, fences. And of course, that doesn't work because if you're a rabbit, it's a fence. You go, I'm gonna dig under the fence. That's what I do. I go underground.
I either jump over it or dig under it.
Yeah, well, not jumping over 4-foot fence or 6-foot fence, but still not going to stop a rabbit. So here's a population density map. This is 99, most recent one I could find. I don't know why, for a deer. So you can see most of the deer are going to be right along in here, right? Now, do you know if you look out in the woods and you see a relatively clear forest floor, that is a sign that you've got too many deer because they munch on that undergrowth. And if there's no undergrowth, they're starting to get hungry. And you see that a lot around here because of all of the construction. So the more construction going on in an area, for example, and more habitat destruction, the more overpopulated the smaller ecosystems are going to be. So like where I used to live, when we had the woods behind our old house and they were about to do even more construction, they've done a lot right around the outside of where we live. And I had an arborist come once to look at a tree and he stood in my backyard, looked down, and all he could see was that stripped land. And he said that he works for the DNR, Department of Natural Resources, as a he does selective reduction. So he will go out, he's an archer, so he'll go out and take out bucks in particular because the bucks are going to obviously be able to produce more offspring than the does. So he goes out there and takes out bucks in areas that are overly populated with them, because otherwise they will starve to death. And I don't think I'd have it in me to shoot a buck. I don't think I can do it, but I would also hate even more for it to starve. That's pretty terrible, right?
Would you rather a quick death or a slow?
Yeah,
death?
kind of pretty much what you're down to. So then you've got, taking my time. So then you've got population density. That's obvious. This is your number of individuals in an area. And this can apply to whether it's animals, plants, whatever, humans. So when you're looking at the population of a city, for example, sometimes it's more telling for you to don't. So just nudge her. So sometimes it's more telling to look at population density of an area. How tightly packed are those people versus how many people are there? You could have a big city spread out. And we talked about limiting factors. So that's food, water, space, weather, also access to mates. If somebody takes out bucks for the Department of DNR, is reducing access to mates for the does, there will be fewer offspring, right? Because if you've ever noticed, if you ever watched deer, like we get them all the time back here, there are far fewer bucks than does, and for a good reason, right? One buck can take care of several does in a breeding season, and he's strutting around thinking he's something awesome, and he probably is.
Really see how like the brain difference is from female does to male.
Oh yeah?
It's completely different.
Wow.
The males are like really,
Guys, Dylan's talking.
the males are like really dumb. Like really dumb.
Yeah. Well, they have one job, right?
Yeah.
Then when you think about it, bucks really have one job.
And you don't
It's impregnate the doe. That's the job,
you don't
right?
ever
And
see-
the does have multiple jobs. Keep the baby safe, find the food, right?
You
Mhm.
don't ever see the bucks in the wild. Like we don't see fully grown bucks ever. We see only like
The young ones. Uh-huh.
We see,
We've got a couple, not very
every
many.
once in a while, we saw an 8-point buck.
Did you?
Right, in our property. We've seen definitely a few bucks, but mainly during deer season, it's like either 7 in the morning or like later in the day, you just hear.
Yep.
And we have a neighbor down our ravine that
Mhm.
has a deer
We-
stand.
The guys down here, if you go down by my river, there are tree stands, but it's primarily archery. And that's because they don't want to be shooting in the neighborhood because they're technically not allowed to even do the archery, but nobody will hear that. And then your carrying capacity is, it's the largest population of any individual organism that your ecosystem can support. So there's a carrying capacity for everything, for humans. And this is a funny thing, when I was Googling images for carrying capacity, man, most of it was about people. It was all these people that were very concerned that Earth was going to, reach its carrying capacity for humans because there's so many humans. And yeah, a lot of it was kind of crazy. It was like,
in New York.
yeah.
You've been outside of New York.
Yeah, exactly.
Well, there.
I mean, they were showing pictures of India and China, and they're like, we have reached our carrying capacity. So a quick trick to remember, immigration versus emigration. So your immigration is when you're coming in. So think of it, immigration in, and then your emigration is your exodus. That's leaving, goodbye, leaving out. That's just
Bye-bye.
yep, just a mnemonic, your E and your I. So these were in your notes too. I'll leave that up for a minute if you've got them out, but basically talking about what geographic range is and distribution and exponential growth, which is when you've got more coming in than you do dying off, right? And you've also got population size increasing slowly and growth rate slowing when you're, this is your second phase of your growth of a population. So populations start growing really fast. They reach a point where they start to slow down and then they reach their carrying capacity. And that's kind of where everything sort of levels off and you don't have a population that's growing like crazy. So think about for a minute, because we've got just about 5 minutes before I usually let you go and stretch before Spanish. Can you think of any species here that's invasive other than those spiders and the crazy lizard? Yeah. Kudzu. Yeah, you're gonna go with kudzu. So who knows anything about kudzu?
I want to say it was originally intended for cattle feed.
Okay, that was one thing. Michael, what were you gonna say?
Just what it is.
What is it?
It's just a vine type of
Mm-hmm.
Spanish mouse looking thing.
Yeah,
It grows
yeah,
all over trees.
yeah. What were you gonna say, James?
I was gonna say kudzu.
Yeah. So where is kudzu from? Do you know?
I want to say that there was something about Japan.
Yep. Okay.
And it's also and it also has like a waxy layer on it, so you can't spray pesticides on it
Right.
correctly.
Tons of fun.
It has to soak into the ground and then be picked up by the roots.
Uh-huh. What were you
If
gonna
you
say?
go north, there's bamboo.
Yeah, there's bamboo here too. Oh my gosh. On the social media pages for this county, like the Facebook Focus on Forsyth and all those pages, there's always some person who says, I want to grab bamboo in my yard. And then you can watch everybody like bite the person's head off virtually because please don't, you can't stop it. I mean, there are patches of bamboo growing all over this county and you can just watch them.
Where I am, there's like this person that, so when we first moved here, I was like maybe like 20 of them. Now it's like
Oh,
good 100
and
yards of them.
their little roots are so fine, you can't stop it. Now, kudzu, what I was gonna say about kudzu is first, it may show up, maybe on a test or something in your future, or maybe on a homework assignment, you may see something about kudzu. But kudzu, yeah, comes from Asia, right? Japan in particular. Showed up at the World's Fair. Woo! Where we had electric light bulbs too for the first time. This is exciting, right? Everybody's saying, oh, this is cool stuff. And they said, yeah, you can feed it to your cows. But they also said, this is perfect for shade, all you people that live in the South. It's so hot down there. You need some shade. It looks pretty on your porch. Ever seen the flowers? They're beautiful. They're purple, like these little like pods of flowers, really pretty. Yeah, so people bought it and they're like, cool, I'll go plant this at my house for some shade. And now they call it the vine that ate the South because it has taken over. There is nothing here that is a natural predator. The insects we have can't eat it. Doesn't work, like he was saying, super waxy. And it's just not part of that food chain. So it spreads like crazy. And there are places where you can go where it's taken over entirely and there are trees and houses. And it's like playing, what picture do you see in the clouds? You can see like monsters and things made of kudzu in the trees. It's ridiculous.
Are they
Dylan.
vines? 'Cause I don't know.
Are they what?
Are they like vines?
Yeah, it's a vine and it spreads like mad.
Because
Mhm.
like where I live, there's a good amount of trees just covered in vines. I don't know
Uh-huh.
if those are vines or-
Well, kudzu's vines, and they're kind of heart-shaped leaves. They're big. The leaves are big like this.
Amazing.
And it's,
I'll
yeah,
take
it,
a picture.
Yeah, our neighbor-
It's
our
crazy.
neighbor's backyard, she's
So
covered
we
in kudzu.
constantly have to
Mhm.
be pulling any kudzu that comes in.
yeah, if it comes in, you're keeping it. It's pretty much how it goes. Yes.
There are species of bamboo that grow so fast, they'll grow like 4 inches in a day.
Yeah.
So you
And
can
they-
just
yeah.
sit there and watch it. grow.
People use that for, you know, for barrier. People use bamboo very often for a barrier. They don't want to look at the guy who lives behind him anymore. So they plant some bamboo, like, that'll hide it because it's tall and it's got the little, you know, leaves off to the side. That'll work. And then before they know it, it's everywhere. So this week, while you're out and about, keep your eyes open for things like that that don't belong in particular. Look for kudzu. Make a note of where you see it.
Secret mussels.
Look for the look for the bamboo and look for those Joro spiders. And hopefully you won't see the frightening lizard. So this week, if you need me, the best way to get me will probably be to text me. I will do my best to get back to y'all, but it may take me a few days. So, and wish me luck because tomorrow we're going to the doctor with my dad to get his results from his neuropsychology evaluation to see how well his brain is functioning after his strokes. And I'm pretty sure this guy's going to tell him you really shouldn't live by yourself and he's not going to be happy and it's not going to be fun the next couple days. So not looking forward to it.
My grandma's best friend had like 3 strokes and like passed away as of like last year.
Yeah.
But it's a really sad thing.
It's weird too, because it's different for everybody and it's different every time. And the 2 kinds of strokes he had were different. The first one he had was a bleed in his left temporal lobe, which is part of your cerebrum. So that's the part of your brain that does, you know, your thinking and your moving and all that sort of stuff. It's not so much your autonomic or the functions you don't think about, right? And that was a bleeding one. And the second one he had was not bleeding. It was a blockage, but it was on his brain stem. And that's the part of your brain that does stuff you don't control. Like it does it on its own. So a lot of people that have that kind of stroke, and they're not common, but a lot of people who have that kind of stroke apparently get this thing called locked in syndrome, which I'd never heard of before and I had to read about it. But the only thing you're able to move are your eyes and the rest of your body is completely paralyzed and you're stuck, which sounds like a nightmare. So fortunately that didn't happen to him, but he's had like a total personality change that he doesn't see, but everybody else sees. He's like a different person and it's really weird. So
I
yeah.
had the worst 6th grade year ever.
Oh, yeah.
So my teacher in homeroom,
Mhm.
I was talking to her and she had a brain aneurysm in front of
In
me,
front of you? Oh my goodness.
and that was like the most traumatizing thing
Oh,
ever. Oh no, that wasn't the worst part, right?
it got worse than that.
My science teacher got cancer.
Oh my
My
gosh.
math teacher left, and my social studies teacher retired midway through.
Maybe we need to all just stay away from you. If you've never seen, yeah, me, if you've never seen a stroke happen, now nobody saw my dad, either of my dads happen, but if you go, I was gonna say, if you go online, you can find videos of Senator Ron Paul had a stroke in the middle of a media interview. Like he was talking and suddenly he wasn't making sense. And it was really weird because you can actually see it affect his face. You can watch his whole face change, like the whole look on him changes and he can't communicate.
My brother had a stroke in front of me.
Oh,
Yeah.
You're who?
Then he had a stroke, remember?
It's a seizure.
That was a
That was
seizure.
a
Yeah, seizure. Yeah. Yeah.
My
Thank
mom-
God those are a little different.
my